Okay, so we're going to continue with water. Last video, we talked about some important aspects of water. And definitely know San Diego equation that 80% of the water that is used in San Diego County is imported from outside of San Diego. So know the percentages that comes from the Colorado River, how much state water San Diego County uses, and the percentage of their local water. Know the Metropolitan Water District. They serve 6 counties. They serve all of Ventura County, all of Los Angeles County, all of Orange County, and all of San Diego County. It also serves western Riverside County and western San Bernardino counties. So definitely know that it serves 18 million people. Who the Metropolitan Water District, or what NWD is. Understand the 2/3 rule, that 2/3 of the water resources originate in Northern California as snowpack in the Sierra Nevada mountains, and that 2/3 of the demand, the users of the water, are in Southern California. Also understand that the resident time it takes for snowpack to occur in a mountain, and for that snowpack to infiltrate the ground, and then for that groundwater to permeate and go through the soil, that residence time is about 9,000 years for Orange County. In desert environments out in Death Valley, it's about 12,000 years. It all has to do with the type of rock it goes through. So today we're going to look at surface water. This is where most of our water originates from. We're going to look at surface water and the type of streams. We're going to look at streams that occur in mountain areas, such as the Santa Ana Mountains, the Sierra Nevada Mountains, Rocky Mountains. And then we're going to look at the type of streams that occur in areas that are flat. As it turns out, these river systems are completely different. They're unique based on topography. So what rivers really do is they erode, they tear down mountain systems. That's what rivers really do. Water is by far the most erosive force in nature. They also transport sediment, and one of the best examples of a river that's actively transporting sediment, the Mississippi River, nice brown river. It's taking sediment from the Missouri and the Ohio valleys. So the Missouri River, the Ohio River, they converge with the Mississippi River, and all that flows down to Louisiana. In fact, Louisiana is like a little peninsula that sticks out in the Gulf of Mexico. That peninsula, that soil, that topography, that piece of land came from basically the Ohio Valley and the Missouri valleys. That sediment was robbed, taken from those areas, transported down by the Mississippi River, and then deposited at the end of the delta. So they certainly do transport a lot of rock, clay, sand, and it depends on what they transport, is how fast water is moving. So river systems will deposit material, floodplain, they build deltas, and we'll look at some of these features that rivers do. So there are 2 major types of streams really. There's high gradient and low gradient. So what's gradient? Well, gradient is basically high elevation minus low elevation, and it's the difference between the two, divided by how far that river travels. And I'll give you some equations that kind of put this in a math perspective. And then there's low gradient streams. These streams have very low topographic relief. So a good example, the Mississippi River. It'll drop from 100 feet elevation to 90 feet in elevation over a distance of 10 miles. Other rivers over a distance of 10 miles will drop literally thousands of feet. And that's the primary difference between these 2 streams, is that the high gradient streams, the water moves much quicker, faster. It can pick up larger amounts of material, carry with it larger particles. Low gradient streams are generally slower, and instead of cutting down into a canyon, they kind of cut across floodplains, so they make very wide floodplains. So topographic is the main importance. So the high gradient streams are found in topographical areas associated with the mountains. So high relief, change in elevation over distance. So a good example of this is if you had 1,000 feet of distance over 10 miles. So let's say a river coming out of a mountain over a distance of 10 miles drops 1,000 feet. Well, you take that 1,000 feet drop divided by 10 miles. That means for every mile that river travels, it's also going to drop 10 or 100 feet in this case. That's like an airplane. So let's say an airplane is at 1,000 feet and it's flying into John Wayne Airport, that plane, for every distance it travels, so if it's flying from, say, Santa Ana, or maybe Orange, to John Wayne Airport, that plane is going to drop to make the mark of the runway. If it drops too quickly, it's going to land short of the runway. If it doesn't drop enough, it's going to land past the runway, and that would not be a good thing. So the Mississippi River, on the other hand, it'll have a 20-foot drop in elevation over 10 miles, which means 2 feet per mile versus 100 feet. And this is the main difference between these two types of river systems, is relief. High minus low. And the gradient is high minus low divided by the distance, and that gives you the gradient. So the characteristics of high relief rivers, you have very steep canyons, very poorly developed floodplains, very fast, swift-moving water. These rivers tend to be erosional in nature. They're actually cutting canyons down. Down cutting is their primary purpose. So if you drive up in the Santa Ana Mountains, if you drive along Santiago Canyon, the roads up there, those roads kind of follow river basins. And those river basins are actively cutting down, almost like taking a hot knife and cutting into butter. So this basically is a profile of a high gradient stream, very high relief, so you get a lot of elevation change over relatively short distance. So this profile would result in water moving very fast. And this is typically what these streams look like. Mountains, not a huge floodplain, a little bit of a floodplain here, but not much. It's actually up in Idaho. The interesting thing about these mountains, there used to be glaciers in here. That's why they're kind of rugged like this. This is typical what you see in a mountain area. High relief, you're going from high elevations on to low elevations, short distance, very fast moving waters. These river systems are going to have rapids in them. They're going to be carrying much larger material. And their primary purpose is to cut down through the rock. And this is basically what we see in a high gradient stream. This is a picture I took out of a commercial airliner. This shows the Colorado River, which is cutting through the mountains. This is actually right at the Arizona. This would be Arizona, this would be California. And this river is pretty much straight. It's cutting straight down through. It's very erosional in nature. It's cutting steep canyons. And then, so headward erosion. The Colorado River has cut down through all the sediments, exposing them, and in so doing, formed what we call the Grand Canyon. So the Grand Canyon was kind of formed this way by rivers just cutting away at the top and then cutting down. And the Colorado River is still cutting down through the Grand Canyon. Come back after the dams are all washed away, and, a couple million years from now, and the Colorado River is going to cut down, making the Grand Canyon even deeper than it is today. And that's typically what these rivers do in these mountain areas. So here's the Colorado River. You have to realize that if you were to go back in time 3 million years, the Colorado River was up here. And it's actually cut down through these sediments over the past 3 to 5 million years. And it still would be doing that today, except we kind of interfered in this process temporarily. We put a series of dams in place that kind of slow the river down. And just to give you an idea of the magnificence of this canyon and this river system, this little silver thing right here is a 15-person raft. So I took this picture from a raft looking at friends that were in this raft here. And you look at this sheerness of these cliffs. Just amazing what this river has done. So I realized that the Colorado River used to be up here. And it's cut down through all these sediments over the past 3 to 5 million years. And that's a black screen. Why do we got a black screen? I don't know. All right, low gradient streams, good example, Mississippi River. So low gradient, Mississippi River, these river systems kind of meander. They go back and forth across the floodplain. Rather than going straight, they meander. So slow moving of water, and they deposit material in the floodplain. So as it turns out, along the Mississippi River, these are great places to have farms, because year after year, the floodplains would flood. That's why they're called floodplains, by the way. Hard to believe, huh? We call it a floodplain, and guess what? They flood. But guess what we do to floodplains? We tend to build in them, and then people get their houses flooded. Like, gee, I wonder why that happened. Yeah, I kind of like to watch it on the news sometimes and just shake my head like, okay, you live in a floodplain, you're going to get flooded. So floodplains are pretty neat because every year that they flood, you have a new layer of sediment enriched with organic material, and that make really good farm fields. The problem is that as farms developed, there was a need for the farm kids to go to school, so they built schools, they built grocery stores, and then retail stores, and then, you know, it just progression, and next thing you got a city where it all used to be farm fields. This is a good example of a meandering stream. They flow back and forth like this, meandering. So these are the meanders. And then what they'll do sometimes is like this meander and this meander might connect here, and they'll make a little cutoff here, and then this will actually fill in and form a little half-moon, half-circular lake we call Oxbow Lakes. As it turns out, these rivers are constantly changing course. So back in the day when they put in the political boundaries for the states of Mississippi and Arkansas, they literally drew a line down the middle. It says, okay, this side is Mississippi, this side is Arkansas, and they drew the political boundary right down the meandering stream of the Mississippi River. Well, 150 years later, as it turns out, the river has changed course. That's what rivers like this do, they change course. So the political boundary no longer follows, in some places, the Mississippi River. It has changed. So these rivers are always changing. These meanders will come out this way. They move across the floodplain, and they're constantly changing. So here's a good kind of a cartoon drawing. Here we have the river flowing around. Sometimes it will make a little cutoff here, and then this will fill in with sediment, and it forms a little half-moon lake. We call these Oxbow Lakes. So definitely know what an Oxbow Lake is. An Oxbow Lake is basically an abandoned meander that got cut off. So this one here could get cut off. So the water might start going through here, and then eventually it's going to fill with sediment, creating this half-moon lake, which we call an Oxbow Lake. This round thing right here is the meander. That's the meander. And on the outside of these banks of the meanders, the river is cutting. So it's cutting, it's moving it that way. On the inside of the meander, the water's a little slower, so they deposit sediment. And this kind of shows this process going on here. So as the water flows along this river, centrifugal force forces the water to the outer bank here. This creates what we call a cut bank, which is labeled right here. This is a cut bank. And then it deposits sediment. So at one time, this river used to flow through here. But over time, it's now moved. So back in the day when they set the political boundaries for Arkansas and Mississippi, they drew the political boundaries. It's time, now you'll see the political boundaries, they'll go like this, because that's where the river was 150 years ago, when they drew those political boundaries for those states. So these rivers are constantly changing course. They're cutting themselves across the floodplains. They're constantly just moving sediment. So rivers like the Mississippi River, they really do three things. They do some erosion, but they also do a lot of deposition, and they do a lot of transportation. So the three things that a river like this does: it transports that material, it erodes it, and it deposits it. So it's constantly mixing things up. And this is why floodplains are really good places for farms. A lot of nutrients in the soil, and because they would flood periodically, you would get a new layer of sediment. That sediment would then have enriched it, organic material, and that organic material provides really good farm soil. And there's the black screen again. I don't know why we're getting black screens right now. Okay. So low gradient streams, Mississippi River, they cut across the floodplain. Very low down cutting. They basically cut across the floodplain. With the high gradient streams, they're going to cut down. They're going to form big canyons, and the Grand Canyon is a good example of a river system that has done that, exactly that. So here is probably not the best view. You probably see it better on the PowerPoint. This is the Mississippi River, taken out of a commercial airline. You can tell by the orange gas tank. It's a Southwest airliner that was flying from Florida to California. So here is the Mississippi River. It kind of meanders back and forth like this. And this river picture kind of looks a little blurry because this projector that I bought, it's not the high quality that we have in school. It was a lot less than what the people paid for in school. So here's one of those Oxbow Lakes. This is actually Lake Enterprise. This is right near the Arkansas, Louisiana, and Mississippi borders. Eventually, these Oxbow Lakes fill in with sediment, and this is actually a good place to come back in, a couple of million years, and you'll find coal here, because this is very rich in organic material. The mud that's at the bottom of this lake, if you were to walk out in this water, and as you walk out, you would see that your shoes would be covered with black, slimy sediment. Very enriched in organic material. These are cypress trees that grow right into the water. And that Spanish moss hanging down. Almost looks like you should see a little guy coming out with a little boat with some moonshine jokes or something. So this is down in Arkansas. And so this is one of those Oxbow Lakes. This is basically a cutoff of a meander. So at one time, this river used to flow around like this, through here, around like this, through here. And it took shortcuts. It cut off this part of the river. This is eventually going to fill in. You can actually see some old meander scars. And so the floodplain of the Mississippi River, from edge to edge across the entire floodplain of the Mississippi River, these floodplains are about 50 miles wide. And they flood. That's why they're called floodplains. The sad part of it is we've built a lot of major cities in these floodplains, and occasionally they flood, and we'll get into floods here a little bit here. So floodplains, they flood during peak season, during runoff, snow melt, and humans increase the flooding events by building in floodplains. We also make human-made levees, and this is what's kind of funny. What we've done to the Mississippi River is right now at New Orleans, the Mississippi River is higher in elevation than New Orleans, the city. And the reason for that is, here's the floodplain. So I'm going to kind of draw the floodplain here. So here's our floodplain. And this would be the river. Year to year, this is where the river's flowing, okay? So the river's flowing in there. Everything's cool. So here's our river flowing in there. And then springtime comes along, lots of snow melt from Ohio and from Missouri. All those rivers flow in, and the river starts to flood. The floodplain gets flooded. And so people say, well, we can't have this. We can't have all this flooding going on. So we need to do something about it. So the Army Corps of Engineers comes along. I'm going to redraw my floodplain here. I'll draw a little bit bigger though, just to illustrate. So here's my floodplain. It floods. They say, you know what? During this summer runoff and this spring runoff, we're getting, flooding, and we just can't have it. So the Army Corps of Engineers comes along, and they build a levee all along the river. That was not a very good levee. Very crooked levee. There must have been some kickbacks there. All right. So then springtime comes. All the snow melts in Ohio, Wisconsin, and here's the river flowing up into this flood. Yay! Good job, engineers. They saved us. They saved all the snow from being flooded. The problem with these levees, though, is because the Mississippi River has so much sediment in it that now the river sees its base level as being changed. And what it starts to do is it starts to fill in the channel with sediment. So it starts to fill in this little channel with sediment. So then, next flood season comes along, and the old timers are scratching their head. And they say, wow, it seems like year after year that river is even higher than that levee. I mean, 10 years ago it didn't get that high. Now all of a sudden it's gotten that higher. 20 years ago. And that continues. So year after year, more and more sediment is built up to the point where now the river is flowing higher elevation than the floodplain. So in New Orleans, the Mississippi River is topographically higher, has a higher elevation than the town. So see the problem there? Big problem. So now, all of a sudden, runoff comes along, and, oh my God, you know, it's right at the top of the levee here. What are we going to do? Next year it might flow over the levee and we'll have a big flood. So what are we going to do? What can we do? Build a higher levee. And that's exactly what they've done. And so the river continues to fill in this. And so people say, well, why don't we just dredge all that sediment out? We just take that dirt out of there. Well, when I show you some pictures of the Mississippi River, you'll see why we don't do that. So one of the things we do at floodplains is we like to fill them in. So we'll take the natural floodplain, we fill it in. This increases the incidence of flooding because during high waters, instead of the water occupying this area here, it can't. We took a bulldozer and we filled them with sediment, then we built houses and buildings on top of it. So now the water goes to a much higher level, so we increase the extent of the flood now. That's what we do, we increase the extent of the flood. And people scratch their head and say, well, it's got to be climate change, right? Let's blame it on climate change. No, it's nothing to do with climate change. It simply has to do with the fact that we're building in these floodplains. The area the river should inhabit is not being inhabited, and it floods outwards. So here's a good example. This really isn't some big tragic event. This is not due to global warming or anything like that. This is simply due to the fact that we build buildings in floodplains. So you can see that they actually put some sandbags on here. They tried to prevent it, but there's only so much you can do sometimes. The force of nature is just powerful. And so the best practice, don't build in floodplains. But we've done it, and people have their lives there. It's not like they can just get up and move. I'm sure people back in the Midwest where this happens probably look at us in California, well, y'all got them earthquake things out there, why don't y'all just move? Where, to Ohio, where we can get flooded? Or get a tornado, Kansas? So the funny thing is about this is that the irony here is that we just simply ignore nature, and then every now and then nature knocks on our door and says, I'm here, wake up. So this is a good example of a levee. We build these levees are going to fill them with sediment, and instead of the flood being this high, it's just going to go higher and higher every year. And this is what's occurring in the Mississippi River Valley. So we kind of put off the disasters to the future. We kind of put it on the next generation. Say, you guys take care of it. You know, you figure out something. You know. So base level. All streams want to cut down to a base level. So they're always cutting down until finally they get to the point where they can't cut any lower. And that's when they stop cutting. And so the ultimate base level is sea level. So in our area, we have the Santa Ana River. So the Santa Ana River flows out of the Santa Ana Mountains. There's a bunch of tributaries that come in. It actually flows, really its headwaters are up in the San Bernardino Mountains. Flows through San Bernardino, goes along the Riverside Freeway, right to Corona. Makes a nice little U-turn, a nice little turn, close in Orange County. And the lowest elevation that the Santa Ana River could ever cut down to is sea level. It's only going to do that at sea level. So it can't cut below sea level, say in Orange. Can't do that. Right along the 57 freeway. You just can't do that. Otherwise it would just stop right there and the Orange would become a lake. So the lowest level that the Santa Ana River could cut down is the sea level, and it does that almost right where the Santa Ana River discharges into the Pacific Ocean. That's the Huntington Beach, Newport Beach boundary. So here's a good example of a river that's hit its base level. It's flowed down to this basin here, and as soon as it hits this lowest elevation it could down to, it drops all of its sediment. So everything that it was carrying, its load, its velocity decreased, therefore its competence decreased, and it basically dropped all the sediment right there. So sediment transportation. Competence of a river is simply this. Faster water can move larger particles. Slower water moves finer material. That's competence. So speed is determined by elevation changes and how much water you have. So the competence of a river is really based on how fast water moves. The faster water moves, the larger particles it can carry. So the Mississippi River is a good example of a slow-moving river. it doesn't transport gravel and boulders. It's depositing and carrying very fine-grained silt, suspended particulate matter. And so see how large this river is? I took this out of a commercial airline flying to New Orleans, and these are all huge barges. These are huge barges. Look at the width of this river. I mean, and it's all brown, so this river has lots of sediment. Here's one of the levees right here they built to keep this inland farmland area from flooding. And you can see that this river is actually higher than that farmlands. The reason that Hurricane Katrina was so bad is that as the water flowing down the Mississippi River met Hurricane Katrina's swell coming from the Gulf, water flowing down means water coming upriver now. It was just too much for the levee systems. They collapsed, they broke, and basically flooded out New Orleans. And it'll happen again, and that's the sad thing about it. So this is the terminal point of the Mississippi River. Once it hits the Gulf of Mexico, its velocity decreases dramatically. It loses competence, and therefore it drops its sediment, and it's building a great big delta out here. And all of this dirt, that is the delta of New Orleans, came from Ohio, Missouri. And so this is what rivers do. They're magnificent water. The number one erosive force of nature is water. That's why we know Mars had water at one time, because you can look at some of the landforms on Mars and realize that they can only have been formed with the aid of water. So at one time Mars had water. So surface water runoff, when the infiltration rate, that means the amount of water can be soaked into the ground, is exceeded or surpassed by the amount of water in a rainstorm event, then you get surface runoff. And a good example is parking lots, like our parking lot in Golden West College. When it rains, the asphalt there does not allow water to infiltrate, so it just runs off. And parking lots are a really mess because they have lots of oil, antifreeze, brake fluids, all the things that leak from cars, transmission fluids. First rain that comes, October, November, or sometimes December, depending on when the rain is, that first rain is such a dirty rain because it washes all of that material off our streets, our parking lots, goes into the Warner Channel, and then it's going to go into Bolsa Chica, and then eventually out to the oceans. I won't even go in the water right after a rainstorm like that. I wait a week or so because I've heard of people getting really sick out there. And definitely don't want to get sick because, you know, people leave diapers out in parking lots and people don't clean with their pets. And all that can contaminate water. So surface water is a problem. So we get overland flow, we get runoff because the infiltration is basically not enough to keep up with the rainfall. So the rainfall intensity is greater than the ability of the soil to absorb that water, you get runoff. So parking lots and streets actually add to that, so those surfaces are almost impermeable. And so it depends on what type of soil texture you are, it depends on the slope of the land. It looks at the nature of the vegetation. So desert regions, as it turns out, places like Tucson, Arizona, Phoenix, Arizona, Las Vegas, Nevada, Barstow, Palm Springs, desert communities like this are very subject to flash floods because they'll have a rainstorm event that'll occur. Over a 30-minute period, they might have a half an inch to an inch of rainfall. There's no vegetation to absorb the impact of the rain. There's no soil to absorb the water. It's mostly rock. And they get an awful amount of runoff, and that runoff collects into gullies and into flood channels. And in the desert communities, we basically ignored a lot of those flood channels, and I'll show you one that has been largely ignored that goes right through Las Vegas. So deltas and alluvial fans, they're very similar. Deltas, like the Mississippi River Delta, it occurs at the end of the river. Alluvial fans we find out in the desert. These are above water. They're both sediment deposits, fluvial systems. They occur at the end of a river system, end of a wash, end of a stream. The difference between a delta and alluvial fan is deltas are formed sub-water, underneath the water, and alluvial fans are formed above the water surface. And I'll show you a couple of pictures of alluvial fans. So delta, it's a deposition of sediment at a stream at the end. It forms when a stream enters an ocean or a lake. The stream loses competence, its velocity decrease, therefore its ability to transport sediment decreased, and it drops its load. If you want to see a good example of a delta, right where the Santa Ana River discharges in the Pacific Ocean, at the Newport Beach, Huntington Beach area, what people refer to as the jetty, that's a good example of a delta. So here's an alluvial fan in the desert. These are mountains right here. So these are mountains. This is low topographic area. I think this is like 2,000 feet above sea level. These mountains up here have elevations of 6,000 to 7,000 feet. When it rains, all that water gets channeled through this little wash right here. And as that water is going through this wash, it's going very quickly to this canyon. Very high amount of relief between here and here. Short distance, a lot of gradient. And as soon as that river hits this basin, this valley, it loses speed, it loses competence. And it basically drops this sediment into this half fan shape called an alluvial fan. The best place to see alluvial fans is in Death Valley. So Death Valley has by far the best alluvial fans. And people come from all the world to study the alluvial fans in Death Valley. So here we have an alluvial fan coming out of this valley, another one over here, another one here. And when a bunch of alluvial fans all come together, we call this Bahada. So the sad thing is that we're supposed to take a field trip here to Death Valley. Well, we stay in this area. And of course all the field trips got canceled. I'm down doing virtual video field trips. Completely different way of looking at things. Huh? So floods. Floods occur, a lot of it they're natural, but humans kind of increase the incidence of floods because we basically ignore geology. We ignore the natural floodplains of river systems. They're the most common and the most destructive geological hazard of all of the hazards. More people, on average, are killed in floods than in any other catastrophe. Tornadoes, hurricanes, earthquakes, it's generally floods. Except for in 2010, more people actually died in earthquakes that year than in floods because we had a whole string of earthquakes occur together. The Haitian earthquake, Santiago, Chile. We had just a whole string of earthquakes that occurred. And there was actually one in Mexicali. And so a lot of people died in those earthquakes, which surpassed floods for 1 year. But on average, year to year, more people are died, injured, or killed because of floods. So urbanization, Orange County, as we urbanize, we cover up what little soil we do have. We replace that with asphalt, concrete. That rainfall is going to run off of those surfaces, thereby impacting the severity of floods. We build in floodplains, we fill in floodplains. There's all sorts of flood and flood control. There's regional floods. This occurs in large river systems such as the Ohio and the Mississippi River. These are those areas that you see on the news where large areas are affected. Flash floods generally occur in desert regions. They can kind of occur here in Orange County, where you have a fair amount of topographic relief between mountains and basin floors like we have. Ice jam floods, we don't have to worry about those. Those are floods that don't occur too often. They're basically in the northern latitudes of the United States where ice will break during the spring, get caught up in a bridge, an overpass, goes across a river. Dam failures can cause floods. And so this is a natural river. So river, year to year, this is where the water flows. During peak runoff, springtime when there's a lot of snowpack melting, these rivers will swell and they'll flood those floodplains. And unfortunately, what we do to those floodplains is we like to fill them in. Everybody likes to have their house or office building right next to the edge of the river. We see that in a lot of major cities. We tend to channelize rivers. We want to take nature and say, okay, all of this is ours, and we're going to put you here in this nice little channel right here, and we want you to stay in that channel, don't leave it. And that's kind of the way we treat nature sometimes. So flood control, engineering efforts mostly, artificial levees, that's what we did along the Mississippi River. Dams are a good way to stop water. We channelize, good example of that, the Santa Ana River. It's all concreted in. It used to kind of meander across Orange County. Now it pretty much goes straight. And that's because we've channelized the Santa Ana River. Detention basins are really big out in the Inland Empire, and especially along the 210 freeway. What a detention basin is they basically dig a big hole in the ground. And they let all the water flow into that hole. And that serves a good purpose because then that water can then actually infiltrate into the ground and recharge groundwater. It also keeps it from running off into the ocean, carrying all the contaminants. Then this is my sarcastic side of me. The non-structural approach to sound floodplain management. Yeah. Do you think that happens a lot? I don't think so. Yeah, it doesn't happen very often. So this is our approach to flood control right here. We like to channelize it. So when I was a grad student at the University of Nevada, Las Vegas in hydrology, I took a course called Water Resources Management. And one of the job projects that I got assigned to was to map a wash, a flood control channel called the Flamingo Wash. Named after the Flamingo Street that it kind of crosses and flows along, which was actually named after the Flamingo Hotel, which was started by Bugsy Siegel back in the 40s or the 50s. So here we are in August, graduate students out mapping the Flamingo Wash. So that was our job, to map the Flamingo Wash, to see how wide it was in some places, the depth of it, what the characteristics of the channel looked like, and to get some ideas. And we put some computer graphic models to show what this river system would look like during flood seasons. And so we mapped it. As it turns out, one of the problems in the Las Vegas area is that there are a bunch of entities. Everything's not Las Vegas. So most of the Las Vegas Strip is not in Las Vegas. It's actually in Clark County. And they have like little divisions of Clark County, like Winchester, I want to say, and Paradise Valley, and they have different names. So there's a lot of entities, kind of like Orange County, where we have Tustin, we have Orange, we have Costa Mesa, Fountain Valley, Huntington Beach. Kind of the same thing. Vegas is much like that. And so in the early days of flood control, you would have different entities. So here's a good example of a natural wash. Flows a state highway, a state-funded highway. Nice big culverts they put in here to move lots of water. And then when it leaves this, it kind of goes right into this subdivision of homes. Literally. Kind of floods right into some of the neighborhoods there. So one of the big problems that they had in Vegas in the early years of flood control is that all these entities they had to deal with. Now it's all under the Clark County Regional Flood Control District, which is a county mandate, and they basically come into cities and build the appropriate channels. It rains in the desert, so every now and then in places like Phoenix and Tucson and Palm Springs, it rains. Because these areas lack good soil development, because there's not a whole lot of vegetation, and there is steep topography, mountains to valleys, a lot of the rainfall that occurs in these desert regions in communities like this results in runoff and floods. So we started mapping the Flamingo Wash. And I took this picture of the Rio Hotel looking towards the south and the west of the Las Vegas Valley. This is the Orleans Hotel. So I took this picture in 2004 when I was a grad student. And here is the Flamingo Wash. So it kind of flows along. It crosses this street right here called Valley View. You see these little culverts. And then it's going to flow along Flamingo Road. So this is a picture I took out of the Rio Hotel looking down. This is actually Flamingo Road. This is Rio Drive. It kind of curves around like this and then merges into Flamingo and goes to the front part of the Rio Hotel. So here's the Flamingo Wash. It goes underneath Rio, goes along these apartments, makes a 90-degree turn, flows and goes underneath Flamingo Road, makes another 90-degree turn. So how many natural washes do this? None. This is a good example of where we channelize. We say, look, we want to put nature in this place here. We don't care where nature wants to be. Naturally, this is where we're going to put it. So then the Flamingo Wash goes underground. This is it right here. It flows underneath, I think this is Dean Martin or Sammy Davis or one of those streets. It then goes underneath Interstate 15 and goes right and literally flows underneath the Caesar's Palace Hotel Forum Shops. So there's a Caesar's Palace Hotel, and there's a shopping mall called the Forum. If you're in the Forum Shops, you're basically walking right on top of the Flamingo Wash. So when the Flamingo Wash crosses I-15, it goes on the back side of the Caesar's property, and this is what it looks like. There are these culverts that literally go underneath, today, what is the Forum Shops. There was an article in the paper a couple times about homeless people living in these, and the contrast between homeless people living in these culverts, and then above them are people shopping in expensive stores, eating gourmet meals, and so forth. But the real problem with the homeless people being here is that when it floods, they get caught up in this sometimes, and they've had deaths attributed to these flash floods. Because they don't have a TV. They're not sitting here in their little culvert with a TV saying, flash flood warning. So this is a picture of a magazine that I found. This magazine is probably dated in the early 70s. I actually found this in a pile of magazines, so I took a picture of it. Unfortunately, a lot of the detail didn't come out. But I love this picture because this is where the Forum Shops of Caesar's Palace is today. Back in the early 70s, it was a parking lot. But I like this. Look at this Corvette sitting here. Beautiful Corvette. There's a Mustang, a GTO, and there's a Pinto. A little variety of cars here. That sign, and we can't read this, I'm sure you're not going to be able to read this in the PowerPoint, but it says danger, subject to flash flooding. And here's all these cars here. So same parking lot, this is probably in the early 70s. This is that same parking lot now, 1975. This is prior to the building of the Forum Shops. It was a parking lot in 1975. Flash flood occurred, and this is the day after when all the cars are all twisted around, banged into each other, and the mud's all over. The water, I guess I actually went into the Caesar's Palace fountains out front. And so today, this is where the Caesar's Forum Shop sits. After leaving the Caesar's property, the Flamingo Wash goes under the strip. When I took this picture when I was a grad student, this was the Imperial Palace Hotel. This is now called the Lynx. So in the back of it, there's that great big huge Ferris wheel thing that goes slow, and people get in it. And I guess there's live bars in there and wet bars, whatever. But this was the entrance to the parking garage of the Imperial Palace Hotel. So this basically serves as two purposes. One, it's a drainage system for a basin. So I took this picture right after we got done mapping the Flamingo Wash. I was kind of curious about this area, so I went back after a storm event in the following spring, my second semester there, and this was that flood event that occurred. After it leaves the Lynx Hotel now, it runs down the street. So this is where the Lynx is now. Prior to the building of the Lynx, these were all apartments here. And this street had two purposes. One, to move automobiles. And second, it's kind of got a shape to it where it kind of concaves down like this. It was designed to transport water. At the end, where these two cars are, there's a great big drain that would take the water, take it underneath Cobalt Lane, and put it back into the natural drainage system again. This is the end of the street there. So this is Cobalt Lane, and this is a great big drain where all the water is going to flow in this little drain. And during a storm event, this is how well it worked. Or it didn't work in this case, right? Too much water for the drain gets clogged up with things. And when we were mapping the Flamingo Wash, I was just amazed at the amount of garbage that people put in these washes. Mattresses, jacuzzis. We actually found a car. It had been stripped, the seats and the stereo and wheels were off of it. And we called the cops and let them know that abandoned car. Did you touch it? No, we didn't touch it. Go take fingerprints. Not ours. We're just reporting it. So this is how well that worked. Not well at all. This is the Flamingo Wash on the east side of town. So I took this picture after we were done with that semester. This is now in the spring semester. I think this is like March. Rainstorm occurred. I remember this trailer house because I remember them putting in this concrete berm right here to keep the flood channel from eroding on the bank. Now, fast forward, graduating, yay, you know, got my master's, ready to leave, right, all that good stuff. And in the spring, actually, you know it was summer because I remember my application's in. Big storm event occurred in Vegas. It was called a 25-year flood event. Caesar's Palace got a lot of water. They actually closed their parking lots. And so I was curious, I wonder how that trailer house did. So here's that trailer house in 2005 with the concrete here. I went back there. This is 2 years later. This is 2007, summer. Same trailer house. Larger flood event basically took out that concrete barrier here. So see, we can channelize nature. We can say, no, nature, you guys sit in this nice little place that we're putting you in. But eventually nature comes around and kicks us in the butt and says, I'm in charge here. And in this case, nature was in charge. So this house trailer now became a houseboat, basically. Sad for the people who owned it. I'm sure they probably didn't realize what kind of an area they were living in. The irony is that this trailer court is called the Miracle Mile Trailer Court. I think the miracle is that it didn't get flooded before. The bad thing about these channels in Vegas is that people dump so much garbage in them. And so in this case, all that garbage washed across a culvert that would drain underneath a highway, and that highway flooded out because all the garbage acted like a dam. A lot of the streets are built right in floodplains. So even though we see buildings and signs, sometimes we can't recognize floodplains. We build right in, we disguise them. But even though we disguise this floodplain, when it rains and nature needs to move its water, it doesn't care what you put there. And in this case, that's the case. There's an underpass that always floods. It's called the Charleston Underpass. Charleston is a street that goes between Interstate 15 and the streets that feed downtown the Strip. And notice the sign here says 14 feet 3 inches. We watch this thing fill up. Kind of neat to watch this thing fill up. People decide to drive through floodwaters, their cars stall, and then turns out they float away. There's that black screen again. This place always floods. It's built right in the floodplain. In fact, I went by there. That place is still here. Still there, I should say. Little Darlings. They just expanded I-15. And it'll be interesting to see what happens when there's a major storm event, because I think I-15 kind of impacted the flood zone. It probably filled part of it in, making the severity of the next rainstorm event probably more severe. It'll be interesting to see what happens when there's another flood there. So the problem with these river systems that we see in desert communities, because they're dry, you know, when the first railroads came across the western United States, the surveyors went out there and they saw all these dry streams. They go, well, these were streams that occurred only during biblical times. And don't have to worry about it, you just fill them in. Well, the railroads learned really quick you don't do that, because first there's a storm that came along, big monsoon, basically they lost the railroad tracks. So we still have a tendency to ignore the natural drainage. We tend to fill in river systems. And so the day after the flood in desert areas like in Vegas, what's left behind is all this mud, stalled cars that got washed down, and that basically ends fluvial systems. So keep safe, and we have some more videos to do. Putting together one on the San Andreas Fault right now. And I'll get that uploaded. And all for now.